Hello, everyone. Thank you, Justin. Thank you, Paul, Jesse, and Abby for having me today. So my name is Reg, and quite excited to be here to talk about all things data science, which is my favorite topic and the reason I get up every morning. And if you are a tech person and you joined because of the word function in the title, I do apologize. This may not be for you. This is not a coding talk, so I won't mind at all if you leave now because the weather is quite amazing outside. With the mandatory mention of the weather out of the way, essentially what I'm going to talk about today is what is data science, what value it can add to your business, and how I'd go about using data science in my business. Simple, really. Who am I and why you can listen to me? So I started my career as a C++ developer about 21 years ago, and have worked with some prestigious banks, hedge funds, and consulting companies building complex business systems. I've also built and sold a data science or a data analytics startup. I was an early member of a data science team, and I've seen it grow from 4 people to about 30 strong. So I've seen things, to say the least. I currently work for an amazing company called Innovistum as a lead data scientist, and as Justin mentioned, we are an AWS premier consulting partner, specializing in AI, machine learning, cloud architecture, and integration services, etc. So we're sort of like an end-to-end experts in when it comes to anything AWS or data science use cases. Having said that, I'm not here representing Innovistum or any other organization for that matter. I'm here to share my personal experience from my journey in the data science space. So please use the advice you get here from me with caution, as I'm heavily biased away from the conventional media BS about AI, ML, and data science. So this is meant to be more of a no-nonsense guide. So on that note, let's jump right into what I mean by the hype. So when I speak to people, it's quite apparent that AI or ML and data science, they mean different things to different people. For example, on the screen you see that these are the definitions of AI from various sources on the internet. So is it AI when something shows human-like intelligence, or is it can AI reach human level intelligence at all? So these sort of questions can actually cause a lot of confusion. And when you read about AI in popular news, it does make you think that AI has already reached some level of human intelligence, doesn't it? So, but first, let's defog the AI hype. And I'm consciously not trying not to fuel the hype, but trying to show that there is a definite value in this area. This is the famous Gartner hype cycle for AI from last year. I'm sure many of you have already seen this, but if you haven't, let me explain how to interpret this picture. It's quite interesting, actually. This picture lists a bunch of technologies in the AI space along this wavy curve. On the y-axis, the vertical axis, it is a measure of how much of an expectation there is for a particular technology. I do apologize if you can't see the names on the screen, but I'll explain. So on the on the x-axis is the time frame divided into 5 sections. And each technology starts at the bottom left of the curve when it's in its innovation stage, and moves along the curve as it goes through phases of inflated expectations, trough of disillusionment, enlightenment, and then finally reaching a plateau of productivity. Not every technology survives through this journey, though. But I'm glad to say that there aren't any of those in this picture, which is good. But what I wanted to stress here is when picking up AI use cases to work with within your organizations, you should pay attention to what stage those technologies are in, and especially those that would take, say, more than 10 years to reach the plateau of productivity. And try not to pick them. Like, for example, the AGI, artificial general intelligence, and autonomous vehicles. You can see the orange dots. They actually mean it takes more than 10 years for them to reach the plateau of productivity. Before we move on to what a data science function is and why you would need one, and more importantly, how to build it, I'd like to formalize a few definitions. So I define artificial intelligence as the study and design of intelligent agents, where an intelligent system is, an intelligent agent is a system that perceives its environment and takes actions which minimizes its chances of success. And I define data science as a field of study that primarily uses mathematics, statistics, programming, along with domain expertise to extract insights from data. So the key point in this definition is extracting insights from data. And machine learning is basically a set of techniques to arrive at an approximate solution to a mathematical problem by going through lots and lots of examples. So from now onwards, for the rest of the talk, I will only talk about data science, because in my mind, AI is a philosophy, and we don't have anything tangible in that definition. And machine learning is again a set of techniques, or they are a subset of tools we could use. While data science is specifically talks about extracting insights from data. So now let's dive into the exciting part of this talk. So why data science now? Is anything genuinely different now compared to 10 years ago, or even 5 years ago? I think the answer is absolutely yes. So the digital revolution, as Paul and Justin were mentioning just a few minutes ago, is post-COVID. It's actually increasing, right? And this digital revolution is creating a rich volume of data, and data sources like social or image and Internet of Things. They're already mainstream. And we're basically creating a wealth of structured and unstructured data every day. And the second point is that machine learning algorithms are maturing rapidly, quite rapidly. We see new barriers being crossed by these algorithms almost every day. And the third reason is that cloud computing and storage technologies, combined with the emerging new data management and visualization tools, they're all at a price point that that enables mainstream adoption of data analytics. In essence, we as organizations have the raw materials, the tools to refine the raw material, and now all we need is motivation and guidance on how to make use of it. So what exactly can you do with data science? Broadly speaking, we can divide data science opportunities into two groups. Opportunities that give us top line benefits, and those that give us bottom line benefits. If you look at the top line benefits, data science can help with generating new revenue streams, improving brand perception, or helping with customer acquisition, conversion, and retention. The bottom line use cases could be making sure the business is compliant with regulations, or identifying and reducing fraud, assessing risk in a better way, and decreasing maintenance costs with the help of predictive analytics and so on. As you can see, almost every area of a business can benefit from the use of data and applying data science techniques. I'm talking about data science helping in solving business challenges, and not about how AI can write screenplays for your movies, or Sophia, the robot, giving human-like interviews in TV shows. I'm talking about stuff that would actually directly benefit your organization. How would you build this data science function in your organization? I hope you understood the fact that data science is useful, and now let's talk a little bit about how to build this data science function. I'll also touch upon later about doing it yourself, or is there any help available, because the whole data science can be a daunting undertaking. This slide and the whole methodology I have been following over the years is heavily inspired by an awesome talk by someone called Monica Rogati. So thank you, Monica, if you ever get to watch this in the future. We've gone through what data science can bring to the table, but the reality is most companies are not ready for data science. Maybe you've hired your first data scientist and tried a few proof of concepts, most probably with results not meeting expectations, or maybe the data literacy itself is not central to your organizational culture. But the most common scenario is that you have not yet built the infrastructure to implement and reap the benefits of the most basic data science algorithms and operations, much less machine learning. But fear not, hopefully in the next few minutes, you will have an idea of how to go about building a data science function yourself. So, so think of data science as the top of the pyramid of needs, or the hierarchy of data science needs. At the bottom of the pyramid, we have the data collection. Needless to say, a strong base makes a strong pyramid. You have to first figure out what data do you have, and what data do you need, and what's available with you right now. For example, if yours is a user-facing product, then are you logging all the relevant user interactions? If it's a sensor that you have, what data is coming through, and how fast? How easy is it to log an interaction that is not instrumented yet, for example? So the first step is to understand how you collect your data from your data sources. This is the most important step. After all, data is your raw material. And once you figured out your data, the next the next thing that you should look at is how the data flows through your systems. Do you have reliable streams and ETL pipelines? And where do you store that data? And how easy is it to access and analyze that data? Those sort of questions are what you should be asking at this stage. And after identifying that data is available, you need to have reliable data flow mechanisms to be able to do anything with the data that you collect. Which basically means only when data is accessible, you can explore it and transform it. When I say transform, I actually mean cleaning your data. because in a sense, data cleansing is probably the most important and long a step that takes quite a long time. Because data cleansing is required when you discover that you're missing a bunch of data somewhere, or your sensors are unreliable, or for example, a version change in your application or an API meant that a few events have now changed from what they used to be in the past, or you're misinterpreting a flag, things like that. If you find that is the case, you go back and make sure the base of the pyramid is solid again, right? And when you're able to reliably explore and clean your data, you can start building what's traditionally thought of as BI or analytics, before it was called data science. This is where you do some things like very small user segmentation exercises and see if anything jumps out and things like that. However, since your goal is to reach the top of the pyramid with a full-fledged data science function, what you're now building is what you'll later think of as features to incorporate into your machine learning model. So this is an important stage. So at this stage, you also know what you'd like to predict or learn, and you can start preparing your training data and generating labels either automatically or with humans in the loop. At this stage is when you will probably find most of your exciting and compelling data stories to work on. We've figured out what data we have and how to reliably flow it and store it. So now, what's next? With the output of the previous step, so we have something called training data, right? And you probably are thinking, surely now we can do machine learning, right? Yes, only if the output of the machine learning model is consumed internally. Let's say you're predicting your customer's churn. But not for something external facing or customer facing, because we've not reached that level of maturity yet with machine learning. To get there, though, what we need is some sort of an A/B testing or experimentation framework in place. So that's this stage of the pyramid. So we need such a framework so that we can deploy our models incrementally, basically to avoid disasters. So this is also the right time to put a very simple baseline model in place, so that we can measure everything we do in the future against this baseline model. All right. At this point, so we've collected the data, we've cleaned, we've flowed the data, and we can now deploy a very simple machine learning model, and then think of new signals and features that might affect our results. Things like can we add weather data or things like demographics data, and would that make the models a bit better? So we are experimenting by incrementally adding new data sources to our models. And once you have reached this stage where you build and deploy simple models, so we're pretty much there. So we're instrumented, and our ETL pipelines are humming. Our data is organized and cleaned. You have dashboards and labels and good features, and we're measuring the right things. and we can experiment every day. And we also have a baseline model that's debugged and is running in production. And more importantly, you've done this or updated these things a few dozen times, right? So you're now ready to go ahead and try all the latest and greatest out there, or from rolling your own models, or to using other people's models that specialize in machine learning. You might get some big improvements in productions. You might not, because if you remember, we are experimenting. We are still the whole approach is based on experimentation with solid base, right? So the worst case, you learn some new methods, develop opinions, and get some hands-on experience with them, and we could probably go tell our clients about our AI efforts. But the best case is we've made a huge difference to our users, our clients, and our company, which is, in my mind, a true data science success story. Right. And a couple of things I want to mention here is that the data science hierarchy of needs is not an excuse to build disconnected, over-engineered infrastructure for a year. Just like when building traditional MVPs, minimum viable products, you start with a small vertical section of your product and you make it work well end to end. So what it essentially means is you can build that small bits pyramid and then grow it horizontally. For example, at Centrica, we started with an end-to-end question answer system and built its small pyramid, which included data collection, ETL, cleaning and organization of data, labeling the question answers, etc. And after a few iterations, we now have a fully functioning chatbot called Wilbur, which is a great success in text processing and natural language processing field of data science. And we did not build an all-encompassing infrastructure without ever putting it to work end to end, right? So we built a small piece that worked end to end and then expanded it horizontally. So now you might ask, why should I go through all this? Because there are tools out there that do machine learning for me and automatically extract insights. Right. So, well, there are those tools. I agree, but I'm yet to see a tool that would replace your pyramid. Right. So my advice is to strongly try those tools to get started with ML, and use those tools going forward. But make sure you have your pyramid built solidly before, and not rely on those external tools to solve the pyramid for you. As I said earlier, data science can be a bit daunting to take up as an organization, but you should not shy away from it, because there's a lot of benefit that you can get from data science, and you don't have to do everything yourself. You could start with the help from a data science consulting company, or basically to get you started and slowly mature your own data science function. I will end by again restating that data science, when done right, is probably going to be your best investment for your future. So yeah, thank you so much, and happy to take questions.